Hello and welcome to Sean White's Solar and Energy Storage Podcast.
Today, our very special guest is Khanti Munro, and I am going to introduce him by looking up some things on his LinkedIn page, some of his credentials and things like that. But I think the most important credential that Conti has is he's endorsed by Johnny Weiss, who's a saint in the solar industry. How did you get that from a saint, Conti?
Interning with Johnny many years ago, camping out, taking every class that he offered and helping with their lab yard and everything. Yeah, he's a true mentor of mine for sure.
Yeah, super nice guy, and we all miss him a lot. He's in heaven right now. He's in solar heaven. He's having a blast. I'm sure of it. And so you're doing some other things too, besides getting endorsed by saints and things like that. And so you are the senior product manager of ConnectDER. Do I pronounce that right? ConnectDER? Is that the right way to say it?
Yeah. It's a play on the word, right? A lot of people say ConnectDER, but yeah, company's ConnectDER.
And so I know them for making this thing, which you can call maybe a meter base adapter, something like that. I'll let you tell people more about it. I know you do other things. I remember a couple of times you were in my class at Alt-E with the Alt-E conference. And one time you brought one of these in and you were like, this is great. And we're trying to figure out this one code thing about this. I remember you were asking me in class and I was like, you know more about this than I do. I think I said, you're very smart. I know you are. So tell us about what you're up to.
ConnectDER pioneered the meter socket adapter. They're often referred to as meter collars in the space.
Meter socket adapter.
Yeah, MSA is what's more standardized.
Does that make you, instead of a blue collar worker, you're a meter collar worker?
I am now. Yeah, you can say that. Collar is kind of like something around your neck. Meter socket adapters goes in between something, I don't know. But the codes and standards are coalescing around an MSA, so that's what we use. But yeah, meter socket adapters, meter collars, they're not new. Utilities have used them for a long time for whole house surge protection or meter form conversion, stuff like that. But ConnectDER pioneered them for DERs, so solar primarily, and now EVs and batteries.
So maybe
and
like you can tell us about all these different initials that you have there. So DER, MSA, all that. Most people, I don't think, know what that means. Yeah.
Oh, come on, Sean. This is your podcast. Everybody knows what that means, right? DER is distributed energy resource. So not power plant, right? Micro power, solar PV, dispatchable, mobile power, EV, battery storage, all those things. So ConnectDER's mission is really to create products that support DERs, such as those things. MSA is just short for meter socket adapter or meter collar. Yeah. So the founder started 14 years ago. It was basically like, hey, interconnecting solar to a home is a pain in the rear. You got to get into the house or into the service panel, and they've got to find breaker space. And, you know, who touched it last? It's messy in there. There's bus bar calculations and rules and all these things. Why not just plug in at the meter somewhere and we're done? And so that's what ConnectDER's been up to. And most of my experience with ConnectDER products has been as just much more elegant, streamlined supply side connections for PV systems, right? Hundreds and hundreds of systems we just standardized on instead of a supply side tap, as we incorrectly call it.
So supply side, what you're talking about is connecting between the meter and the main breaker. So the meter is still on the utility side, and then there's a connection that you could put solar batteries or EV or something like that between where the meter is saying how much electricity you used, like your main service panel.
Exactly. Yeah, avoiding all the headaches of connecting, on the load side, and even some of the headaches of connecting on the line side via standard methodologies, right? Tap boxes or piercing connectors, things that, have their own downsides. Now you're just plugging in.
That are messy and can smolder and spark if you don't tighten them right.
Exactly. Yeah. So, that avoids that, right? You take out the utility meter, plug in the meter socket adapter, the meter goes back into the meter socket adapter, and now you have this kind of pluggable interface on the outside of the house to connect these DERs to.
And it's been some time since I first saw one, probably like 10 or 15 years ago. I don't remember which company that made it, but I think when they first came out, utilities were very nervous because it's close to the meter. So is that part of your
Well, the reason there's not a ton of competition is, can you imagine if you were engineering new refrigerators or microwaves? And I said, yeah, it's great, but you have to have every single utility in the country approve your microwave design. It's not for the faint of hearted, you might say. So ConnectDER's built out a whole market opening team that's all they do is just work with utilities, educate them on how, meter socket adapters doesn't equal free energy. It's still on the load side of the meter. It's okay. You still get the bill, but there's a learning curve there and you're playing in their sandbox. So yeah, it's definitely part of the equation. You have to have utility.
Like they have those little tags on the meters and they don't like people taking those things off or touching the meter. You hear people that hook up a solar system and just turn it on to see if it works. And it sends a little bit of electricity the other direction. And then like 5 minutes later, somebody pulls up because they're watching you. Big Brother's watching you through that smart meter, of course, we all know.
Yeah.
And they can tell what's happening. And
yeah, I mean, you're out west, in California, MSAs can only be installed by the utility, meter technician. Hard stop, right? Bar none. Then you have other places, Arizona. It's kind of a joint meetup where the installer might still be able to install it, but the utility has to be there, right? So there's some coordination. And then you have kind of the wild, wild west, which is always my favorite. And that's in places like, here in Vermont where I live, but also parts of Colorado, New Jersey, other areas where the installer actually can pull a meter, install a meter socket adapter, put the meter back, and safely put it all back together, which is much faster and easier, as you might imagine.
there's so many different rules. Do you have anything like a map or, of where the rules are different for different places? It might even be like different amongst different utility areas, authorities having jurisdictions, cities, just inspector to inspector of like where you can use that or who you have to talk into using that. And you probably do a lot of explaining, I guess, to inspectors and people making policies.
So I'm on the product team. My past is managing projects and people, and now I'm managing Thing, right? The hardware, which is pretty interesting. But we have team members that do exactly that, right? It's just training, working with utilities. Yeah, there's a section on the website I think it's called Check Availability, where you can see state by state which utilities have approved it. And then we have team members that will just work with the installer to say, oh, you're working with X utility. Okay, they're a little more difficult, try this. But yeah, it's part of the equation for sure.
And so then I assume you can have a map and you can like get a pen and you can color in the place that lets you use it. And then your goal in life will be to have the whole map colored in. Is that the way it's going? It's not going backwards, is it, anywhere?
No, well, some utilities try and go backwards. There's a lot of utilities that are trying to go forwards and some that are kind of stuck in their ways for the last 100 years, right? Until some of their team retires, which happens every year. But yeah, the momentum is building. For example, most folks are familiar in California with Rule 21, right? There's a new
you
Rule
can tell
31.
us about it, though.
Well, just about, interconnection and interconnection rules and islanding and those type of things, right? In terms of interactive systems with the grid, just high level. But Rule 31 is hot off the presses, and that has to do with customer-owned meter socket adapters. So these are real now, right, in the eyes of the PUC and other entities in California. So the momentum is definitely building, as more and more. So PG&E and the big IOUs in California just approved our islanding adapter, which is our latest meter socket adapter. So yeah, that is the end goal, is to get them universally approved. But as you've alluded to, it's not like a one shoe fits all, right? Each utility has a different take on it.
So maybe you could tell us about these different types of meter socket adapters. And I know I was talking to Bill Brooks too and he was recommending using one that wasn't going to go under the utility meter. Like you would just put your own meter there somewhere. And so you could have some of the benefits of using that. And so I remember talking to you a while back, some years ago, you had one that was for charging EVs. So if you have somebody with a house with 100 amp service and they want to stick on like a 40 or 50 amp EV breaker, the service couldn't handle it. So it would be sort of like a supply side connection, but then it could communicate with the EV and slow down the charging with the EV charger communications.
Yeah.
Do you have a name for that one?
So 3 main products: solar meter socket adapter, solar MSA, EV MSA, and now our Islander. You picking up the trend here.
All right.
MSA.
Yeah.
So
they have a sailboat called an Islander. You should get an Islander 36 like Chad Medcroft used to have.
Okay, there you go. I thought for sure we weren't going to get the trademark on the term Islander because there's a lot of them from people to seafood restaurants and boats. But we got it, which is interesting. Yeah, so solar MSA is a supply side solar connection. EV MSA, as you alluded to, is a load. It supports a load, but because it's on the supply side of the service disconnect, still on the load side of the meter, the main breaker can't protect that load, right? It's net add of load. And so inside the EV MSA is some basic load management functionality whereby it monitors the whole house consumption and says, oh, okay, if the house plus this branch circuit feeding the EV or the heat pump, for example, or a hot water heater, a controllable load, exceeds the continuous current rating of the service or the instant rating of the service, it'll just open a relay and basically shut off the EVSE, the EV charger, temporarily wait for, you to stop cooking or get out of the hot tub and close the lid and the load to come down, and then relay closes and the EV starts charging again.
Yeah, hot tubs are very important. I call those critical loads.
Critical, exactly. Yeah, that's medically necessary to many of us. Yes, sit in a tub of hot water, I know. And then lastly, the Islander is what we're just bringing to market now. We're just in pilot phase in PG&E land right now. And that is for storage, both stationary storage in the basement, in the garage, or mobile storage, vehicle to home type of stuff. So that provides whole house isolation with an MID or a microgrid interconnect device.
Maybe tell us how that works.
So Connector makes meter socket adapters, not inverters and all kinds of other fancy electronics. There's plenty of people doing that in batteries. But as you know, in parts of the country, like California, where you have a meter main combination panel, right, where your meter socket and your breaker box, same box, basically.
Same box, yeah.
Outside. It's very, very difficult to cut in a transfer switch or an MID, right, microgrid interconnect device. Never mind CTs or current sensors or islanding microgrid type of operations. So you end up doing all these fancy, expensive things like moving all of your circuits into a sub panel or replacing the whole service equipment altogether. It's very expensive. So what Islander does is same idea, same form factor, right? It's this wonderful grapefruit form factor, as I call it. And you put it behind the meter and it has that whole house transfer switch in it. And then a communications cable that goes to third-party energy storage systems that have partnered with us or integrated with us. For example, Franklin, Whole House, Lunar, SolarEdge, a number of others. And it's a bidirectional communications, right? So we're sending the voltage and the current data to these systems, and they're waiting for the grid to go down or to have a fluctuation that's out of spec with their UL 1741 power control system decisioning. And then they send the command back to say, okay, grid's down. We got to back up the house. And the Islander opens the MID, the switch, and isolates the house. And now the battery and the backup system provide backup to the house. And it all happens, blinklessly or very quick.
Pretty cool.
It's super neat, right? I mean, it's not like you can't do that other ways, or with like a gateway type of box. But again, if you have those meter main combos, you can't really cut it in. You have to do quite a bit of circuit relocation work to make that happen.
Yeah, so like a lot of these companies, like you said, Gateway, I guess that's the Tesla one.
They all have them.
And it's like their name for a microgrid interconnect device. And yeah, they all have them. And so what they do is they disconnect from the utility, and then they signal the inverter to go into backup mode. And so they all have their own special one. And now you come up with one so people don't need those special ones. Are people out to get you? Are there like people parked out in front of your house in black cars? Like the Gateway people, the Gateway Mafia?
Well, yeah, ironically, everybody that has a Gateway is wanting to talk to us because the Gateway is an expensive box that needs a lot of help to be able to integrate it. So the same companies that all have Gateways, except for, say, Tesla, who has their own similar device, they all want to talk because they're looking for a more cost-effective way, especially now, with the ITC going away and everybody looking to figure out how to save on their install.
I guess there's like just different ways to set these things. And they'll work with CTs, like current measuring devices. Current transformers is what you call them. It works over, you put it over a wire and it tells which way the power is going and how much, alternating current. And so it would be also a type of an energy management system, or part of an energy management system, I guess you could say.
The Islander, the MSA, is not in itself an EMS. You can hear my dogs barking here.
That's good.
Or a PCS.
We like dogs. Yeah. You could hear my cats barking too. Yeah.
But it becomes a critical component of the third-party energy storage system's PCS. You're basically moving the MID, the switch, from the gateway to the MSA. In itself, it's a standalone device. It's governed by a different UL standard, which is UL 414, which has to do with meter sockets, meters and meter sockets. But once one of these ESS, energy storage systems uses Islander, integrates with Islander, they relist our control system to include Islander as a critical component.
So they have to have software that's compatible with your software. And perhaps, are you sort of setting a standard for this type of thing? Like, is it an open source type of software, or can anybody use it?
Yeah, so right now we have two formats. One is an analog format, which is just sending the raw data, raw voltage, current, whole house
Analog, is that sort of like cassette or DVD?
Yeah, it's more of like, cassette, I guess.
Vinyl.
It's basically saying, hey, everybody wants a different communication layer, right? And most of them are a digital protocol. That's your CAN bus, your mod bus, and all those things. So the initial version, the analog version, just says, hey, you guys figure that out. Here's your raw data, and you convert it to whatever digital protocol you want on your side. But where we're headed is a digital version where we output, where you can just plug an Ethernet wire, directly into the product and get all the data you need to make that PCS decisioning.
We interrupt you for a very important announcement. Sean White's Solar and Energy Storage Podcast has been brought to you by Sean White's Solar and Energy Storage Podcast. That's right, Sean White is sponsoring his own podcast, and he wants to remind you to go check out some of his classes. You can go to SolarSEAN, that's Solar, SEAN.com, and then click on the links to check out his classes. You can check out his heat spring classes, and you can also hire him to teach classes for you, like at your company, something like that. Now back to the show.
And what makes an energy management system? So it would be like a system, so it would be like different components, and it might be your device, like an Islander, and also some inverter company that you're working with. Yep. And other things too. How does that work with energy management system listing or power control system, energy management system, kind of interchangeable? Or correct me if you have a better answer.
Well, yeah, I mean, you may know more than I do on this front. It's changing, and we've gone from EMS to PCS to EMS. I think we're back in the PCS range, although I haven't read
2026 NEC is back to PCS, yeah.
Back to PCS, right? And now we have a new UL standard, UL 3141, which is pulling that PCS part out of UL 1741. Yeah, I'm getting out of my lane a little bit, candidly, Sean, because this is where we're really leaning on our inverter and energy storage partners who already have to get these listings for their systems to just say, hey, keep doing what you're doing. Just take our device as a critical component, right, as the MID, and just wrap it into your listing, right? So when they go to list their system and show that they have the metering, the inverter, all the brain power to do that type of fancy decisioning, they just have to show that the mid moved from one box to another. It's not that hard.
So maybe you can list off the different inverters that your Islander works with?
Yeah, so at RE Plus last month, we had 4 of them in our booth, and that was Solar Edge, Franklin, Lunar Energy, which they're newer, but they're out in the Northern California, great group too, and then EcoFlow was the other one. They just come out with the ocean system, which is pretty interesting. Those are kind of the top 4 that are coming to market first with us, but we have about 20 plus more that are in different stages of integrating with Islanders. That's pretty exciting.
All right.
A lot of interesting partnerships developing.
So you're keeping pretty busy. And did you invent a lot of this stuff? Like, do you have patents?
Well, ConnectDER as a company has probably a dozen patents and, a handful more pending. I think my name is on one and pending on another one, which is pretty neat. I've never.
Wow, your name's on a patent. Oh, I'm not worthy.
Yeah.
Did you ever see Wayne's World when they go
yeah.
see Alice Cooper and they're like got backstage passes and Alice Cooper comes up to Wayne and Garth and they get on their knees and they're like, we're not worthy.
Yeah,
Okay.
Yeah. Well, no.
So you're a patent holder. Yeah. Wow.
I'm one of many on the patent. That was for the EV one, and then the islanding one is coming up. So, yeah, no, it's neat stuff. It's definitely a niche space that I think will help a lot in kind of the 2026 market of like, how do we make installing cheaper and faster and quicker and more standardized? Because, we lost the tax credit.
What would happen if I took your different adapters? So what you have the EV one, you have the Islander, and what do you call the other one?
Solar MSA.
The solar one for a supply side connection. What if I put all three of those on top of each other? What would happen? What if I put 17?
The homeowner would fire you because it would look like a terribly weird phallic thing sticking out on the side of your house.
I'm into that kind of stuff.
I don't know. Yeah. Well, we specifically say in the manual, you're not allowed to do that.
Oh, man. But who follows instructions? Come on.
I know. Give Greg Smith a call and ask him for his RTFM t-shirt. I need a new one, I think.
I know. And he probably just tells us to follow instructions. And then I bet you go to his house, it's like he doesn't follow instructions.
Do you think he barbecues the way of the manual for his...
Oh, I'm sure, yeah. Yeah, he's got his Weber manual out. What's that?
I see you, Greg. He's going to come after me for that one.
Yeah. And so if people don't know, we have links to the podcast. Greg's been on the show a number of times, and we'll put that in the notes. And he's famous for RTFM. Read the something manual because he works for different solar, inverter, and battery and optimizer type companies that people call him every day. And he just tells them to read the manual because they ask him questions and it's all in the manual. And we know that one of the problems with testosterone is it makes people not read manuals.
I hadn't heard it put that way, but yes, that is true. I also think it's small point font and long booklets of information. We have to figure out how to way that. I think I was talking to Greg about this recently. How do we make them into, 2-minute informational clips?
What's kind of cool is you can now like upload it to your AI and then you can ask it questions.
Oh, that's true.
And then you could like be driving down the road and just be like, what happens if I put it in upside down with 3 different islanders on top of each other? And it'll tell me that it's against the rules.
Violation of 110.3b.
But if you did put 17 in a row, then you would have to start making these things that balance it on the end. Like you have instructions like you take a 2x4 and stick it on the 17th one to support it.
So 2 things I have to say to that. So first is, this is a thing in the standard in UL 414 supplement C. Basically, they're worried about a kid or snow falling off your roof, knocking a meter socket adapter and a meter out of the socket, right? Because you're making it protrude out now. So there's a new requirement that you have to be able to sustain, I think it's 75 pounds of weight pulling down on the meter socket adapter. Because that was an argument from the utilities that says, oh, no, somebody's going to hang on this or snow will fall off your roof and it's just going to pop off, right? So we have to meet more rigorous testing on that front. But the other thing I wanted to say, Sean, was that the next version of Islander is actually trying to address that very, why would you put 17 leaves in a row?
I hate it when people start quoting UL 414 supplement C on me, It's like...
I got to quote something on you. You know the NEC more than I do. But the reason is because you want to put multiple DERs behind one meter socket adapter, meter collar. So
but
the
you'd be
second
making
version,
more money if you could sell 17. Yeah.
Well, that's true. But the second version will have a power connection. So it'll bring back the AC power connection up to about 100 amps to the adapter. So now you have the switch, the telemetry or the data connection, and now you have 100 amps of supply side interconnection point. So now you can have a sub panel that has your solar, your EV, your storage, everything kind of built in, all connected to one point on a meter socket adapter. So you don't need to go in the house for interconnecting power, and you don't need to go in the house for communications. It's all just right there. So that's what I'm working on now, which is pretty cool.
Have you ever put two in series yourself, just while you're doing experimenting?
Only in the lab, yeah.
Uh-huh.
Yep.
And what happened? It's like big fire, something like that.
No, but higher potential of problems.
It didn't fall on your head.
No, not immediately, but it wouldn't take much.
So is your lab near where you are in Vermont?
No, it's in Philadelphia. So
Okay. Do you go there often?
at least quarterly, maybe a little more for team meetings and stuff.
Grab a
Yeah.
cheesesteak. Yeah.
Yeah, it's an interesting city, that's for sure.
Uh-huh. Yeah.
But yeah, no, it's a good company doing good things. It's a nice change from managing residential installations, which I was doing for quite some time. So
No, it sounds like a lot of fun, like doing what you're doing. I remember when I first saw these things, and then maybe a little bit later, there was this video from San Diego Gas and Electric, and I'm not sure if it was your brand or not. It might have been. And it was like only the utility could install it. And they're like, this will save you lots of time and money, where otherwise, if you're going to install solar, you need to do a panel change. And then they're like, they get a sledgehammer and they start tearing down all this stucco and framing so they could put in a bigger, and they're like, this will cost you $20,000 if you don't use our special San Diego Gas and Electric method of doing things, which was essentially just doing a supply side connection. And so I guess the one that's your solar one doesn't really need electronics in it.
no, it's a super simple, dumb device. It just facilitates an interconnection with a two-pole circuit breaker built in.
And it's just like a supply side connection. But that's pretty cool that you fit the electronics in there. Do you run out of space? And like when you're switching things off, what kind of switch is it? Is it like, I mean, it's got to be able to break 200 amps, I guess, right?
Well, so it depends on which product you're talking about, right? The solar product, it only has overcurrent protection on the solar circuit,
Yeah.
right? So
Yeah, not
goes
that
up.
one.
Yeah, the Islander currently doesn't have a power connection, but the whole house MID does break the full 200 amps current going from the utility to the house. So it has to be rated for 200 amps.
So inside the meter the Islander, there's a 200 amp disconnect in there.
Yeah.
And is it hard to fit it in there? Is it sort of like a normal 200 amp breaker?
It's a slightly different form factor, but yeah, I like to joke with some of our team. It's kind of like fitting an orange inside of a grapefruit. It's a very limited form factor. It's also, as you might imagine, it's really hard to pass 200 amps through something the size of a grapefruit and not get too hot, not overheat, which is a problem for utilities. It's a problem for the standards. The connector engineers are incredible. I mean, we figured out how to do it without fans and just dissipate that heat. It's pretty neat.
And how does it reset?
It can only reset by the partner equipment. So the partner equipment is taking the data that we're collecting and sending it to it and saying, is the grid up? Is the grid down? Is the grid good? Is the grid bad? Is everything safe? And it does all that per its PCS listing. And it will say, oh, okay, grid is back. Let's check the quality of the grid, do our sync, and then send the command back to us to reclose the mid and restore power.
So like to reclose a circuit breaker, you have to use a form of renewable energy called muscle. And you take your fingers and you flip the switch. And you're like setting a spring in there. How does that happen? Do you have like little servos in there, or is it some kind of electronic device?
Well, it's a, relay operates a little differently than a mechanical circuit breaker. And I'm not an engineer, so I don't want to butcher the answer to that. But in short, we have a power supply to have that oomph in there to do the actuation part. But we're relying on the partner to send the command, basically, the green light, red light. Can we discharge your capacitor and, open that relay or close that relay really quickly? And we're just constantly waiting for that command to do it. But the relays are different than circuit breaker in terms of how they actually actuate.
And so it's reading the grid too. So it's looking at UL 1741. That's what inverters use and other electronic equipment. And there's different types of UL 1741, but just to kind of generalize, if something is not working at 60 cycles per second, if it's off by less than a cycle per second, or if it is 10% above or 12% below nominal voltage, So like, 264 to 211, something like that, then it has to turn off. And there's different things too that we have, like voltage and frequency ride through and stuff like that for like UL 1741 SA or SB and all those types of things. But is that in the software inside of this meter base Grapefruit?
So I can quote 414. I can't quote 414, but you can quote 1741. No.
Well, I kind of said what it was,
I'm just kidding. No, it's not in the Grapefruit. It's in the partner system, right? So we figured, okay, you're already doing all that stuff. You keep doing that stuff. We'll just send you the inputs, the data that you need to be able to decide whether it's grid following or grid forming. Okay. And that way we kind of stay in our lanes and we keep building meter socket adapters and they keep building energy storage systems, inverters, and then they work together in harmony in that way. Otherwise, you end up with kind of multiple redundant layers of decisioning and software, and it gets a little messy. So we haven't gone that path.
Yeah. Did you know that grapefruits are energy storage? They have calories, which can be converted to kilowatt hours. And
I learn something new every day. I love grapefruits. Maybe that's why I use it as an analogy all the time, where I just think it's the fruit closest to the size of our device. But,
cool. I'd like to check out your factory someday or something and check out some of these grapefruits and see how you fit those oranges in there and all that kind of stuff. It's pretty cool what you're doing.
It'll be a fruity party, I'm sure. Yeah, come on down to Philly, or next time you want to see some beautiful foliage in Vermont, come up this way. I'm actually going to be installing an islander on my house this week, along with the new Franklin battery, which I'm pretty excited about.
All right, so, awesome. Yeah,
you're welcome anytime.
You're in Vermont. Do you know Bernie Sanders?
Yeah, I believe it or not, I was actually part of the team that put solar on one of his houses up in Burlington.
Oh yeah,
I know him barely. Well, I can't say I know him well, but I know who he is very well.
Did he yell at you while you're doing it? Like, hey.
So he didn't yell, but when the system was commissioned and the team was kind of excited to see his glorious reaction, he didn't look happy at all. And his comment, and I'm not going to try and impersonate him because I'll fail, was along the lines of like, what's there to be happy about? If I'm the only one on the whole neighborhood block that can do it, who cares? It was true Bernie fashion, was kind of like, until everyone's got solar on my block, I'm not happy, And it was a very modest, like 5 kW, 6 kW system.
Was there like news crews there or anything like that?
No, it was very, very chill, and had to be American made equipment. He was very particular about some of that stuff. But yeah, Bernie's a good guy. So
he's got some connector devices happening at his place.
I have to go back and look if he got a connector or if he didn't need one or not. That was a number of years ago. I wasn't a connector at the time. Yeah. Okay.
Anything else you want to talk about, or secrets, or gossip, or anything like that?
You have Bill Brooks's other cell phone number? I seem to have lost. No, just kidding.
Yeah.
Yeah. Yeah, it's good to connect. It was nice to see you in Vegas. That's an interesting city. I hear they're doing the show there for a few more years, at least.
Yeah, it sounds like it. Yeah, I think they just can't fit in any other place. They're too big. Unless they want to go to China or Germany or something. Wouldn't that be fun if RE Plus went to some other country?
That would be really cool. Although if I'm with ConnectDER, I probably wouldn't go, because most meters in Europe are not ANSI type meters. So
yeah, we got
to use grapefruits. They use some other type of
like
food.
Kumquats or whatever.
Yeah, I don't know.
Kind of French
IEC
thing.
meters or something. It's weird. But no, thanks for having me on, Sean. I've been looking forward to it.
Well, thanks so much, Khanti Munro, Senior Product Manager at ConnectDER. And how do people find you in ConnectDER?
KMunro@connectder.com, KMUNRO. LinkedIn is always a good one as well.
All right, cool. We'll put some of those things in the show notes. And thanks for listening to Sean White's Solar and Energy Storage Podcast, where you can get yourself educated. You can get yourself a NABCEP PV installation professional certification, just like Khanti Munro. And how long ago did you first get your first PVIP?
I think I've recertified at least 3 or 4 times. So what's that? 12? Geez, I don't know. It's been a while.
Before or after 1980?
After 1980.
After 1980. So that's pretty awesome. I'm also after 1980. And especially since we're just messing around and NABCEP hasn't been around that long. But everybody should get NABCEP certified, just like we are. Woo!